Hey guys, Pankaj here. Welcome back to my YouTube channel. In this part of NLP, we are going to learn chunking, chinking, part of speech and name entity recognition. Okay, so if you remember in the previous video, we talked about stemming, lemmatization, and sentence truncation, right? So once you are done, then you can do chunking also. So let me share my desktop. Okay, so this is what we saw, right? Sentence tokenization and underestimating. We saw Porter stemmer, snowball stemmer, as well as Douglas stemmer, then lemmatization. So let's go to part 4 and let's see what and all I'm going to cover. So we will see what is corpora and how to get access from the local disk, what is part of speech, and how to get the meaning of the part of speech. Okay, so we will first we'll see what is part of speech, then we'll talk about getting the meaning of part of speech and how to filter only given part of a speech. Okay, what is chunking, how to draw chunking, basically visualization of the chunking, and how to define chunk grammar. Okay, how to filter given chunk grammar from tree. So these kind of things which you will not find in any of the videos. I have explored a lot, then I'm making this video for you guys so that you can easily understand what is chunking and chinking process. Okay, then we'll see named entity recognition. So let's see the example now. So as usual, I'm importing this NLTK library. So let me run it. NLTK version 365 and download. I believe you guys have already downloaded, so I'm not going to show that. And sample text, I'm going to take this particular text about Albert Einstein from wiki page. Okay. So let's see how to get the corpora from local disk. So there is one function called state union. Okay. So this is nothing but it is going to show the path of all the different kind of corpus, right? This could be, let's say, presidential speech. This could be some medical terminology, some other English literature. Okay. And different text files will be there. And that text file is going to contain a lot of words about that topic. Okay. So in my PC, it is there in corpora state union. Okay. So let me just go and just share with you guys. So what I'll do, I'll just take this state union, let's say dot raw. Maybe I'll go here. Okay, so under state union, you see, right? We have a lot of different kind of text. 1945 Truman text, different kind of then Eisenhower, then Kennedy. So these kind of speech basically. Okay, Johnson speech, then Nixon, and different kind of topic you'll find. George W.'s speech is also there. So if you'd like to see like what kind of word they have used and during their speech, you can do a lot of analysis from that. Okay, so let's say if I'm just loading, I'll just show you how to load and all so that you guys can just try it. I'll just comment it. So we have state underscore union dot raw. Okay, so if you read about this file, so let me file object file equal to this. Okay, so this file is nothing but the complete text has been given. Okay, so if you would like to analyze full file, then you can go ahead. Otherwise, you can just take part of this file and do further analysis. Okay, so I'm just going to cover it. This is just for example. It's kind of like sample data or sample text data, which you can do further analysis. Okay, so now guys, let's see what is part of speech tagging. So first, you should understand what is part of speech. Okay, so let me demonstrate using whiteboard. Okay, so here, let me take this. Okay, so let's say I'm telling I am going to market, correct? So this is basically a sentence. This is a full stop. So in this sentence, we have this I, that is nothing but your preposition, right? So PP, there's basically, I'll show one link where all kind of, grammatical part of English grammatical part has been mentioned, and what is basically PP with a preposition phrase. Then we have, let's say, determiner. Then we have VB, that is nothing but verb. If it is ending with ing, then they denote as VBG. Okay, then to they denote as to, and market is nothing but noun phrase. Okay, similarly, let's say I am watching company name IBM, just for example. Okay, so here also we have something called this preposition, then we have determiner, then watching is nothing but your VBG, that is nothing but verb ending with G. Okay, and this is kind of another. Then company, again, it's a noun phrase, so you can mention NN. Then this could be maybe some object will be there. Okay, similarly OB is nothing but it will be denoted as ORG. This is nothing but organization, or this is also known as noun phrase. Okay, NNP. Okay, so these are nothing but called part of speech tag. So basically you have given a sentence and you need to filter out what kind of different parts are available in the speech. We have adverb, adjective, so similarly we have, let's say, another one. I have let me just write here. I have a black color dog, just for example. Okay, so black is nothing but your adjective, right? So adjective will be denoted as JJ. Okay, color is also a property, so this will be JJ, and dog is nothing but your noun. Okay, so these are nothing but part of speech which you are denoting. So this will be very helpful when you are going to analyze some particular part. So let's say we talked about word tokenization, right? So what it did, it just filtered all the words as space separated. So let's say this was one word, this was one word, this was another word, this is another word, and so on, right? So all the words you got in the form of list, correct? But is it giving more information? No, right? Why it is not giving? Because until you combine them along with adjective or noun or verb, right, it doesn't make really any sense. So let's say I just talk about black color dog, right? If you filter this particular part, right, it really makes sense. I have dog which is black color, correct? So it is basically combined of three different parts of speech, that is JJ and JJ, then NNP. Okay. Similarly here, I am watching a company. Okay. So if I just take watching or company, a separate word, it is not going to make any sense. But the moment I combine this particular phrase, right, VBG followed by, let's say, some determiner and NN, right? That is noun phrase. So VBG, DT, NNP, if you combine all three together, means it is going to make sense. I'm watching company or watching company. What are you watching? It's a company, right? So if you combine, then only it makes sense. So part of speech plays very important role. Okay, whenever you do any text kind of text analysis. Okay, and if you are able to identify part of speech, then chunking and chinking process will be very easy. So you should understand very well what is POS. Okay, so let me just go back to example and show you how to get it. So let's say I'm just going to take another example. I am going to market and dog. Oh, just one example. Okay, so here I'm going to, okay, now let's see the POS part. Okay, so how to do POS part? So first, what we have to do, word tokenization. Okay, so word underscore, that is the function we have already seen, right? If you just put it, then it is going to print WT, right? So now we have word tokenization, basically trimming all the spaces or splitting all the whole sentence with the help of space. Okay, so now how we can get the part of speech tag, the one which I showed in the whiteboard. So basically I'm talking about these kind of part, how to get it. Okay, so we have direct function called let me just show the function now. So we have word talk. Now we have nlp.pos underscore tag. Okay, part of speech tagging. And this particular function takes tokens. What is my token? WT. Okay, now see here. So this is nothing but PRP. That is what I showed here. PRP. Okay, I forgot to mention that, but this is preposition. Then M is nothing but verb. Okay, and going is nothing but VBG. So if it is goes, it is just VB. If it is going, then it will just show VBG. Okay, that is the present continuous tense. And to will always be denoted as TO. Then market is nothing but NN, that is noun. Then we have comma. So remember guys, I have not done any data cleaning, right? So comma will also be treated as something. So comma or punctuation will be directly a punctuation name. And is nothing but CC. What is CC? So if you don't understand what is the meaning of CC, MD, VB, then we have something called, let me just show you quickly. So what we can do, there is one function called NLP dot help dot we have up enhance, I think. What is that? Up enn dot tag set underscore tag set. Okay. So if you see here, different kind of tags are there. Okay, and complete meaning. If you want to see one particular meaning, let's say what is CC? I don't know, right? So you just put CC. Okay, so CC is nothing but conjunction, coordinating conjunction, something like that. Okay, similarly, let's say you would like to see what is my NNP. So noun, proper, and similar. Correct. Similarly, you have double N, noun, common, similar, or mass. Okay, so these are various meanings which you can definitely filter and get to know what are those. Okay, so if you guys know about POS, then believe me, it is going to be very fun part while doing text processing, because you can do a lot of things which we'll see under chunking. Okay, so that is about getting the meaning of this. Okay, now let's say you have got very big word, and out of those words, I am interested only to see, let's say, the name of person from the given text, right? So if you guys remember regular expression, right? You can put different kind of pattern, but how will you know like that pattern? I'm just filtering a name of a person. You cannot do that because regular expression doesn't know it's a person name or some other name. Correct? It will just filter based on the pattern and return the word. But in the part of speech tag, you can easily do that. Okay, because we have already identified POS tag, right, for each word. So if I'm interested to know only the name part, then you just filter using name. Okay, so this time I am going to take this particular task, and from this particular text, I'm going to filter all the names. Okay, so let's do that. How to filter only POS, right? So I had text. So let's say word tokenization 2 equal to word is text. Okay. So remember, guys, I have not yet done any cleaning, so I'll take as it is. From this part of text, what I'll do, or let's say I'm going to take POS equal to NLP dot POS tag W T and 2. Correct? We got all the POS name here, right? So I'm just going to comment it and I'll iterate over each word. Okay. For let's say tag in POS if POS. So if you see here, POS is containing what? It's a kind of tuple. So under that tuple, first is your word and followed by, or the second element is nothing but your POS, right? So what I'll do, if POS, maybe I'll just do the indexing -1 equal to, let's say, I want all word which is ending with ing. Okay. If it is VBG, then print tag. Let's do that. Luckily, we don't have any such words. Okay, so what I will do, I'll just take NNP. Why it is not printing? Let me just do that. Oh, I just took -1. This is not required. For POS tag, I should do tag -1 NNP. Then it makes sense. Okay. Because we are iterating over each tag, right? So you see from the big chunk of text, we are just getting all the names, Albert, Einstein. Okay, so if you do a proper filtering, then you will not see all those junk characters, Nobel Prizes, physics, Einstein. Okay, so let's take another example. Let's say I do filter all the verb ending with ing. Do we have such words? Yes, developing and becoming. So see how difficult it will be when you are trying to filter this kind of word from regular expression. It is not at all possible. You may get the word, but exactly ending with ing, it will be a little difficult. Correct? Okay, similarly, any word which is having, let's say, CD. CD is nothing but cardinal number. Okay, so you can filter all the numbers from the given text. See how beautiful it is filtering. It is not just filtering the number, it is just filtering the cardinal number also, which is the text part of the number, like 1, 2, 3, etc. Okay, so this is one of the best part of the NLTK. Okay, so now you guys know how to do POS. Now let's talk about chunking. Okay, so what is chunking? So let me go back here and clear everything. Okay, so again, I'm going to write something here. So let's say I'm writing one sentence here, denoting ages. So I am going to market to buy a dog. Full stop. Okay. So if you see the sentence right, it has a lot of POS, right? So POS we already saw. So we have one I, then we have M, then going, then to market, another two. This is two, not a four. Then buy, a and dog, right? So what are those parts? So this is nothing but your preposition, PRP, and this is, let's say, some determiner, and this is nothing but VBG, right? Let me take another color, VBG. Then this is two, then this is N and P, that is noun phrase. Then again TT, then by is nothing but your verb. This time it will be VB, because it doesn't have anything, right? It is not ending with ing, it is not ending with ed or something, correct? It is the first form, so that's why VB. Again, let's say DT, then NNP, that is noun phrase. Okay. So now you have all the things tagged, right? Let's say I'm interested only those part which is having, let's say, some part of what is a sentence which is starting with verb followed by determiner and followed by, let's say, noun. Okay, so those are nothing but basically you are going to give a pattern. I want to filter only those part of sentence which is having VBG followed by to followed by NNP. Okay, and I want to extract them. So what will happen? This is nothing but it is going to act as a regular expression pattern. Okay, so anything in the sentence which is having VBG followed by to followed by NNP, highlight that part in the sentence. Okay, basically it will extract that part from the sentence, and it is going to represent as a tree or sub branch of the tree. So this is nothing but your main tree. Let me just highlight this part. This is your main tree. Okay, and now the moment you give this particular pattern, VBG2 and NNP, it is going to be part of main tree as a subtree. Okay, so your subtree will be highlighted like this. So going to and market. Okay, and now this is going to be your subtree. Let me just highlight. And this subtree is nothing but called what? So let me give proper name here. This will be known as chunking. Okay, remember guys, this is part of chunking. So from the big group of text with a lot of PUS, you are filtering sub part of the tree. That is known as chunking. Okay. So for chunking, you should know what is your part of speech and what kind of grammar or what kind of pattern you are forming. This is known as your grammar for chunking. Okay. So now let's take another example. Okay. I have read color car. Okay, so let's say you have a lot of sentences in a book or given raw text, and I want to filter all the words which is starting with JJ, nothing but adjective, and maybe this color is also JJ, and let's say we have NNP. Okay, so my next part of subtree will be, and the grammar of that will be JJ followed by another JJ followed by NNP. Okay, so this is my chunk grammar to display that particular tree. Okay, so this is your main branch, and if you want to highlight as a subtree, then this grammar needs to be given to the chunk grammar. Okay, and that grammar pattern will be your JJ followed by JJ followed by NNP. Okay, so let's see one example, then you will easily understand. So this is the theory behind chunking. Then I'll explain same thing with the chinking also. Okay, so I'll take one simple example here. A equal to, maybe I'll take similar example here, whatever I have taken earlier. If you understand the basics, right, then you can take any kind of text. I'm going to market and buy a dog. Okay, and then go for dinner. Okay, just one example. Let's print it, and I'm going to tokenize it so that end to end we can see. So word token will be word dot tokenize. Then what is my A? Okay, print WT. That's good. Now let's define a grammar. Okay, first, before that, we will do the token POS tagging. Okay, so POS tag equal to p dot POS and give WT POS tag. This is a function POS underscore tag. This is what we gave. POS tag, right? Okay, so now we got a tag, and now there's time to visualize it. Okay, so visualization will be done exactly the way I represented here. Okay, so let's take it. So for visualization, what we have to do, let's do the visualization first. So we will take it the grammar wise. We have something called chunk parser. Okay, I have not yet imported, so let me import it quickly. So NLP.regex parser, first we'll define the grammar, okay? So grammar, what we told. Yeah. Grammar. So if you see here, right, we are having, let's say we are going to visualize this particular tree, right? VVP or going to market, okay, VBG2 and NN. So let's find that. Grammar equal to I'll give multi-line comment, okay, because you can define multiple comments also. Oh, sorry, multiple grammar. So grammar, how to define? So whenever you want to highlight that particular part, right, using chunking. So we have something called, you can write the group name here. So I just write syntax equal to, and let's say whatever group name you are giving, then followed by colon. Then here it will be exactly same as your PUS. Okay, that's all. And exactly all the pattern, like if you mention some PUS, then dot, means after PUS any single character can come. Some PUS, and at the end you put star. So let's say NNP. Okay, so after N you may have single letter N, no N also, and multiple letter also, right? And plus multiple letter question mark, it may be there, it may not be there. So all regular expression pattern will be valid here. Okay, so these are syntax. So I'm going to give, let's say, chunk. This is my first chunk, so I'll give chunk colon, then give curly braces. Okay, here I use the curly braces. Anything PUS. Okay, so I am going to highlight going to market. Okay, so going is nothing but, let's say I have VBG, then followed by 2. So I'll just give 2, then followed by NN, right? That is your noun. Okay, this is my grammar defined. And now after grammar is defined, right, what you need to do is you pass this grammar to regex parser. Okay, so what I'll do, chunk grammar equal to NLP dot reg expression. What is the name? Reg expression parser, not grammar. And in this parser, you just pass this grammar. Okay, so that it can remember what exactly you are going to find out. So let's see if it is running. Yes. What is my chunk grammar? So chunk regex parser with 1 stages. Okay. Now after that, we are going to take chunk parser dot parse. So where is my chunk parser? Let me just get that particular part also. Chunk parser. Where is that library? Let me just explain that. Okay, it is already part of your NLP, right? So you don't have to explicitly import chunk parser. Okay, so what you can do now? Chunk parser. What we're going to pass? The PUS, right? Chunk parser dot parse. And what is my PUS? So this is your PUS tag. I just pass this. So what you can do, you can get the tree. So once you pass the whole PUS tag, right, to the chunk parser, it is going to create a tree. So I can just get the tree and let's print it. So chunk parser is not defined, and is there any mistake here? Or NLP dot chunk parser. I think there is some typo. Oh, my bad. Chunk. Because this is what we have to pass, right? So chunk parser. NLP is not required. Chunk parser dot parse PUS tag, then tree. This should be good. So now it is going to create a tree internally, like what is my sentence, root sentence, and in that sentence, what is my different part of tag, which is, going to show as a T, or maybe going to show as a stem in the tree. So let it run. Okay, so Chrome driver, because it is based on I think toolkit, some TK library, and it is going to visualize a separate graph. Okay, so we'll see that first. Let it print. Why it is taking more time? Let me interrupt it and run again. Okay, kernel is killed. I may have to run again. So I'll just run this library. Okay, now this is over. Let's go here. And I'm going to run this part once again. It should not take much time because we are just going to get the text form. Okay, nothing else. Com driver save. Meanwhile, let me show what it is going to do that. So it is just going to do, I am going to market to buy dog. Okay, so going to market will be highlighted separately as a separate stem from the S sentence. Okay, so only thing is that that's the only difference which is going to be visualized. And the main root, what do you say, sentence is filtered like this as a separate what do you say, text, and this will also be filtered as a separate stem of the tree. Okay, so I think it got stuck somewhere. I don't know what is the reason. I hope it is going to be over. Kernel is dying. I don't know what is the reason here. This should not die. Okay, this is also fine, and this is also fine. This time, let me directly visualize it. If it is not able to print, maybe dot draw, tree dot draw. Okay, PS tag is not working. Okay, now it has come. I think it was waiting for this particular screen. Okay, so if you see here, right, this is what I showed. Okay, I think it might not be visual. Let me just share it. So along with this, yeah. So in this scene, what is happening? See here, I am chunk. So this is the chunk. Why it has highlighted? Because in the chunk grammar, I have given VBG to NN, right? So this is nothing but your VBG 2 and NN. That is your noun. Okay. So this is what I was telling. It will show the main tree, and from that tree it will filter that particular chunk grammar. It is going to visualize it separately. Okay, guys. So let's say you would like to, from this tree, I want to filter, let's say RB, VB, and IN also. Okay. So what else you can modify? Let me just close it. So I told RB, VB, and IN. So I can do one more thing here, or RB. You see here, I'm using OR operator, right? This is similar to a regular expression, whatever you had done. IN and so sorry, RB, VB, and IN, right? VB and IN. Let's see what it does. See here. So the first chunk VBG2NN, fine. It is found, that's why it is highlighted. And after it is traversing other text also, right? And later it found this also because we have given out either this or this. So both I found, that's why both are highlighted. RB, VB or IN. Okay. Then this chunk name, this is the grammar we have defined, right? So let's say you want to define something else. So let's say branch. Okay. So this branch, it is just going to display the name as branch. So this name is not like you should just give the chunk. You can give any name. It is just to highlight it. Okay. So this is what is your chunking. Now let's say you have something called. So do we have any? Let me just run once again. What I want to show here, you can put some kind of question mark and other character class also. So we have VBG and we have VBP also, right? So assume that I'm having VBG or P. Anything can come, right? So let's see what happened here. So I can make VBG or VBP because both are there, right? So in this case, what will happen? Whichever comes first, it will take that one. Okay. Now let's say after N, we have 2 also. Or maybe I'm just thinking to take RB, VB, G or P. So let's say either G or P. See what happens. Will it give anything? Okay, let me take some other example now. VBG or VBP. See whether it takes or not. No, it is not taking. But you got the idea what I'm trying to show here. It may take VBG or VBP. Okay. So you can just separate using OR operator and you can define whatever grammar you want. Let's say I want to display any kind of word which is like to buy or to go, to eat, something like that, to and VB. So I want something like to along with VB, right? So what will happen? So I can add one more grammar here, or to followed by VB. Let's see what it does. It is going to find that word also. See here. VBG to NN and to VB, then RB, VB, IN, correct? So you can just highlight those kind of things. So just tagging those words or using PS, it is not going to help. PS is having very important role while doing chunking and chinking. Okay. So let's say you have big sentence. I want to filter. I'm going to this country, right? So I'm going to. So after to, you have a lot of country name, right? So you can just filter all the things from very big chunk of data. Okay, guys, so that's about chunk. Now let's talk about how to filter given chunk grammar from T. Okay, so what you can do now. So the moment tree is created, right? So from tree, we have something called for T or maybe subtree. In tree, we have another function called subtrees. Okay, so from tree you saw, right? In the diagram, we have so many subtrees or so many stems. Subtree and ST. Let's see what it does. Subtrees. Yeah. So you see, this is a subtree, that is the main tree, right? Which was shown as here. You see here. These are mainness. From mainness, it is taking all the text representation of the tree. So I am going to mark it, and you see it is going to mention this branch because this is the name we have given for this particular chunk grammar. Okay, so now what you can do, instead of visualizing everything or getting all the text data, now my next target is to filter those words where chunk grammar is passing the criteria. So what I can do, st dot, we have something called st dot label. Okay, so label, you are getting branch. If you can put a condition here, now you know what to do. If st dot label equal to, let's say whatever branch name you have given, right? Branch, then print st. I am interested only in that particular tree. I don't want to visualize whole tree data. I want to extract only those chunk data where chunk grammar is or chunk grammar is satisfying the criteria. Okay. Now you can do all the later processing part, whatever you want to do. Okay, guys, what is chinking? So chinking is just avoid of chunk. From whole chunk, you want to remove one particular chunk. That is called chinking. Okay. So to see that example, what we do, the very simple thing we do, only one change. So you are giving chunk, right? Chunk, column. You are giving this bracket, then your tag. If you are giving this tag, followed by all the tab, and closing the bracket first, then opening the bracket first, right? Then this will be called chinking. Just opposite bracket if you use, then that will act as a chinking. Okay, so let's see the example now. So I'm going to take same example. Okay, so this will be this particular grammar. Okay, so I'm going to remove this particular part. You have to be very careful. Okay, opening and closing bracket. Let's see now. So it has not highlighted that particular part where VPG22 and NN is there. Okay, because we are doing chinking, it is going to remove it. If it had been with the opening and closing first, then it would have highlighted that particular tree. Okay, and let's say to modify a little more here, what I'll do, I'll just take this grammar. So I want to include this particular part, but in the next line, I'll mention I don't want to have this particular VBG2NN. Okay, so this, let's remove it. And now just draw it. Now you see the magic. It is going to include only that particular branch. To and by, because I'm closing and opening the opening and closing the bracket and opening closing another one. But this particular part VBG2NN I have given as opening first, sorry, closing first and opening first, right? So part of chinking. That's why it is not highlighting this particular part. Okay, so this is part of chinking. So those kind of thing will be very helpful when you are interested only in that particular sentence or that particular part in the sentence. Just highlight that. If you're not interested, just put in the part of chinking, but that grammar has to be exact. Okay, guys, let's talk about chinking. Okay, chinking is done. Let's talk about NER, that is named entity recognition. So what is this name entity recognition? Basically, you have a very large set of text data. In that text data, you want to filter only those names which is related to person name. You want to filter only those names which is related to company name. You want to filter only those data which is related to, let's say, dollar data or monetization related data. Correct. So we have all kind of category which comes under NER, named entity recognition. So let's see how to do that. So for that, we have something called very simple. Where is that POS? So what I'll do here, I'll take another one. Visit USA on 23rd December. Go to, let's say, Google Office. Just one example. Okay. Now print a. So here I would like to filter the name of country and some number. Okay. Google will go to Google Office by, I just wanted to mention this should be okay. So you have got a sentence, you would like to filter name, date, country name, and the office name and the person name. Okay. What I'll do, my name is Pankaj. I'm going to read USA on 23rd. Okay, so here it will filter the person name also, the country name also, and the office name also. Okay, that is what is called NER. So let me just show how to filter that. So first create word tag equal to nlp.pos tag a. Sorry, I have to do tokenization. Tokenize a. Okay, then WT. Okay, we got it. So the moment you got all POS, now pass this POS to your NLP for creating the NER. Okay, so we have something called NLP dot. What happened? NLP dot any chunk. In this chunk, I'm going to pass WT. Okay, I think it is going to do same thing here. It got stuck. We have to draw it. Okay. So NER tag this dot tag. Still running. Come on. Okay, we are almost done. So I'll show how the NER data looks like in the tree. So basically what will happen, let me just show the previous example here. So here you see this dog, right? Or maybe here I just mentioned. Okay, it has become slow. So let's wait for this to over. I think it is over already. Okay, now this is over. Then what we'll do, we'll run this tag again. And let's draw it. Okay. And ER is not, sorry, ER tag. Yeah. You see here how beautifully it is finding all the names and just putting the category. Okay. So the person is like Pankaj, organization is USA. I don't know why it is putting USA as organization. That is wrong. Here organization equal to Google. That is correct. Person is Will. Okay. This is completely wrong. Something is messed up. So let's correct it. My name is Pankaj and I think this should be working. I'm going to visit USA on 23rd. It should be fine. Okay, something is wrong. So this USA is basically country. So this comes under GPE. there's a special category where all the country name will be there. Okay, so 23rd, you see, this is cardinal number CD. Okay, and December it is taking as noun, that is also wrong. It should not take. And person, again it is taking Will, so it is like Will Smith, that is also person name, right? So that's why it is taking or identify Will as person. Okay, and organization as Google. This is correct. Okay guys, so that's how. Okay, I think I have not shared it. Yeah, so it is launching another window, so I need to share it again. Yeah, so what I was talking, it is giving all the definition of NER and their corresponding name, right? So like person name is Pankaj, and organization it is taking USA, which is wrong. It should have been taken as GP or something. Okay, and here person Will, it could be taken as a Will Smith, and organization name is Google, which is correct. Okay, so we can take one more example. Let's see quickly. So let's say I work in PyCSR and going to USA. Just one example. Now let's see. I'll share again. Okay, so this time also, yeah, so PyCSR is taking as organization name, and USA also it is taking our organization, okay, which is not correct. But yeah, that's okay. I think once you give a lot of good data after data cleaning, it will make sense to visualize. But overall idea, you got it, how to do named entity recognition from the given test and how to visualize them. Okay. Yeah, so that's all guys for today. I hope you enjoyed it, and please try chunking and chinking from your side. Understand the grammar part, write it, play around with all the verb, noun, adjective, and CC conjunction and all those things, and see how beautiful it is filtering and visualizing the data in the tree. Okay. Yeah, similarly, you can play with named entity recognition and PUS. Okay, guys. So I think a couple of topics are pending, very small topics, so which I'll be winding up in the next video. Okay. So thank you, guys. Leave out all your comment in comment box and press the like button if you like it. Thank you so much. Bye bye.